Okay, the student. Uh, we have up to this part, step 3. I hope uh, due to the spin orbit magnetic interaction, vector S, vector L coupled to form J vector value, which is called total angular momentum, and a magnitude is given by the relation given below. Uh, this is J vector total angular momentum vector is equal to root over J into J plus 1, uh, reduced form of a Planck's constant as mentioned in the above part of the this portion, and the J vector is given L vector plus S vector will remain same constant, and we have known that J value, this is the minimum and this is the maximum, and when the number of J value is given by this 2S plus 1 if L is greater than S, and the number of J value is given by 2L plus 1 if S is greater than L. Uh, then we have not this point. The state of highest S value have the lowest energy, or maximum multiplicity has the lowest energy, as we know, according to the Hans rule. Now, focus on Lande interval rule, uh, that is that reflect the energy interval spacing between the consecutive level of a fine structure multiplied, that is more than one system, one state, and is proportional to higher J value, that is J plus or J plus 1 and plus 2, etc., etc. Here, the energy of two level we can consider like this. This is the energy gap given by delta E, spin and orbit, spin orbit uh, vector interaction. And this is J level and higher level J plus 1. Uh, in the LS coupling, the interaction energy may be written or can be written like this: delta S L is equal to E, the L vector and S vector. We put equation 1 where A is interaction constant, and we have already known that J is given by J vector is given by L vector and S vector. Then JJ, we have this value. Then after multi multiply simplifying, we have this thing, J vector. Then it is uh, from the above part, which is LL, LS, and SL. LS and SS are same, and SS. So we have this. Then we have to focus on the LS because we focus on the LS interaction reflecting J vector. So L vector and S vector is when we put this left side, the sign changes positive to negative and positive to negative, and then divided by 2. That is, we can write this half of this vector. Then this is J vector square, L vector square, S vector. So we put equation 2. Putting this value in the equation 1, we have in the equation 1 we have this is in the equation 1. Let us remember this in equation 1. In equation 1, we have this terms by putting the values in the equation 1, and it is given by this, as we know, this J vector is root over J into J plus 1, Planck's reduced to the power 2. This is power 2 means root in the power. So we put like this in similar manner for this L and S, and this is where this is what, etc., etc. Like this we can write similar to this L and J S. Then come to this opening the root over. When we open, we get and taking the Planck's reduce is the highest pi to pi as common factor, and this is, yeah, we put the common by putting this uh, Planck's reduce. Instead of Planck's reduce, we put Planck's constant divided by 2 times of pi. As in the above part is square, we put the square. When opening the root over, the power get cancelled to that of the over root half. Root over means to the power half. Half into 2. 2 means in the above part power is 2, and into half we have 2 to get neutralized. This is the things we have. Then this 2 into 2 means 4. 4 into 2 means 8. A by 8, the Planck's constant square divided by pi square. This value we put common to all this. We have this value. And this term, these are the constant. A is constant, I is constant, pi is constant, and we put this A. A is vector constant for this, and this term we put as it is. Like we mean 2 means the same thing we can write here. Can write the same thing. In the LS opening, the multiplier have same value of L and S as mentioned in the above. Only the J value changes. Only the J value changes. This one. Here, energy difference in the above part. This is the lower and this is the higher. And the energy difference given by delta E. We put this, and this is the things we have. These are the things, and here to know this thing, we can see like this. This J is written by J plus 1. J plus 1 is given by J plus 2 like this. Here J is J plus 1 and J plus 1 is J plus 2. These are the things. Here we put the same, and here J for the J we put this thing same. We put this thing for the J. For the J plus 1 we put J as J plus 1 and J plus 1 is J plus 2. Means here putting the value J plus 1 instead of J and J plus 2 instead of J plus 1 like this. And by then opening the above square bracket, we have this is the left part, as you know. By opening the bracket, third bracket, we have this thing, and this get neutralized, and this get neutralized. Only this term we have, and here we can take a common term, that is A into J plus 1. Here also A and A and J plus 1. We make this in taking A into J plus 1 as common term. In this we have J, A and J plus 1 is common. Then by taking this, we have J plus 2 here and only J here. And J and J get cancelled because this is positive and negative. So these two means in the multiply form, we can put 2 times of A and J plus 1, which is this higher energy. What is change in energy? Hence, the energy spacing between the consecutive level depend on the larger value of 2J value involved. Larger value or larger, this one larger value, because plus 1, J plus 1, that is higher than the J. So this is known as Lande interval rule. I hope you can understand this portion. If you have any confusion, you can ask. So thanks, my dear student. Cái nó tao muốn coi ra.